Hello students, welcome to our page. Today we are going to consider the next exercise from the chapter number 2, linear equations in one variable and that exercise is exercise 2.5. Now we had considered different concepts regarding these linear equations in one variable in exercise 2.1, 2.2, 2.3 and 2.4 also. We had seen some word examples, we had seen some directly equations, and that we had constructed the equation like this. So all the type of examples already we had considered, but here now in the exercise 2.5 the important fact is that we have to solve the linear equations. So here question number 1 is like this: solve the linear equation x upon 2 minus 1 upon 5 which is equals to x upon 3 plus 1 upon 4. So here if we consider the type of the equation, then all the terms are actually in the form of fraction, or we can say that wherever that variable is there, so those are the fractional terms. That means numerator and denominators are there. So we had considered about such a type of examples, but we had not considered like this all the terms are fraction or most of the terms are fraction. So here the first thing is that in order to simplify such equations, you have to perform all the operations very carefully, because here the fractional numbers are there and we have to consider those fractional numbers, and if whole number is there, so you have to consider those combiningly, either fractional number or whole number, so that combiningly you have to consider the concepts. So that's why such examples are very important, and today we are going to see such a type of examples. Now the first number or first linear equation is like this: x upon 2 minus 1 upon 5 which is equals to x upon 3 plus 1 upon 4. Now here before solving this equation, that means the basic step is that in the previous exercise or in the previous questions we had considered that what we are doing, actually we are bringing variables to one side and all the numbers to other side. So here we cannot do that thing directly, we have to perform that operation also, but first of all we have to consider the LCM, that means least common multiple, which is common in all the numbers, that we have to consider, and after that only we are able to solve the given equation, then only it is possible to solve the given equation. Now here if we consider the force table, then that means you have to consider all the denominators. So here first denominator is 2, then second denominator is 5, then third denominator is 3, then fourth denominator is 4. So we have to consider all the tables: 2's table, 3's table, then 4's table, then 5th table, like this. So all the tables we have to count and we have to find out which number is common in all the tables. So here actually if we count the 4's table, so actually it is odd and even numbers are there, so that's why we have to consider the tables according to that, we have to consider LCM according to that. And if we count all the tables, then it is found that the 60 is only the common multiple which is possible, that means least common multiple is possible, that means 60 is the smallest common number which is present in all the tables. So that means we can say that the LCM of all these denominators 2, 3, 4 and 5 is going to be 60, because actually 3's table and 4's table are there, so some numbers are not coming in those tables. So if we are going to take the numbers, like suppose if we consider 3 tens are 30, so 30 is actually even number, but 30 is not in the table of 4, so that problem is there. So due to which the 60 is the least common multiple of all the denominators 2, 3, 4 and 5. Now whatever be the LCM is there, first thing is that you have to calculate the LCM, and with the help of that LCM you have to multiply both the sides. You have to multiply both the sides by that least common multiple which is 60, and after that we are getting the steps like this: 60 into x upon 2 minus 1 upon 5 which is equals to 60 into x upon 3 plus 1 upon 4. And here if you consider 60 is present on both the sides and we can cancel it, so that means our original equation is does not changing by performing operation on both the sides. Now we have to multiply by that 6 inside the bracket, so therefore it will be like this. First we are going to write down it like this: 60 into this first term, 60 into x upon 2, so that will be 60 divided by 2. Then next term is 60 into 1 upon 5, 60 into 1 upon 5, then it will be 60 divided by 5, because 61s are 60, so that's why 60 upon 5, which is equals to again 60 into x upon 3. First multiplication is 60 into x upon 3, so that will be 60x divided by 3, and last one is 60 into 1 upon 4, so that will be, here we are getting the 60 divided by 4 because 61s are 60. So here it is the simplified form after performing the multiplication inside that bracket. Now we know that here we can perform the divisions. So 60 is actually divisible by 2, so we can say that 2 ones are 2 and 32s are 60, so here only 30x is going to remain. Then 5 ones are 5, then 12 5s are 60, so here we are getting 12. Then again 23s are 60 on the right hand side, so here we are getting 20x, and here 15 4s are 60, so here we are getting the 15. So that means all the numbers are divisible by the denominators. That means 60 is divisible by denominator because 60 is a LCM after all, so that's why they are all divisible. So therefore after dividing by the denominator to that numerator, we are getting 30x minus 12, 30x minus 12, which is equals to 20x plus 15, which is equals to 20x plus 15. So here this is the next step. Now we have to perform that transposing operation to bring all the variables to the left hand side and all the numericals or numbers on right hand side. So that's why we are transposing this 20x to the LHS and minus 12 to the RHS. So here this minus 12 is going to become plus and this 20 is going to become minus, so therefore we are getting 30x minus 20x, which is equals to 15 plus 12, which is equals to 15 plus 12. Then therefore 30 minus 20, it will be 10, and here on the right hand side 15 plus 12, that will be 27. So we are getting 10x is equals to 27. But here solving the linear equations means we have to find out the value of x. So that's why dividing both sides by coefficient of x, which is 10. So therefore we are getting the final answer as x is equals to 27 divided by 10. 27 divided by 10, because we are going to divide by 10 on both sides. So here 10 is going to be cancelled because same number from the numerator denominator, it will be cancelled. So in this way, by solving this linear equation, we are obtain the answer x is equals to 27 upon 10, which is also actually fraction, and the given equation is also in the terms of fraction. So it is not like that always the final answer is coming the fraction. Maybe it will be the whole number, or maybe in the given equation some part is of whole number, so some part is actually whole number. So that thing is also going to happen. So that type of example we are going to consider in the question number 2. So question number 2 is now like this: solve the linear equation n upon 2 minus 3n upon 4 plus 5n upon 6, which is equals to 21. So here just I had mentioned like that example is there. Some part is whole number and remaining part is fractional number. So in other words, we can say that LHS is a fractional number and RHS is a whole number. So don't panic about that if any one whole number is there, so there is no need to panic about that. So you have to again follow the same steps which we had followed in the previous one example. So again we have to take the LCM. Now here that LCM is very small because 2, 4 and 6 tables we have to count, and in all these tables the 12 is the number which is common. So you know that 6 2s are 12, 2 6 are 12 and 4 3s are 12. So 12 is the least common multiple which is taken for these denominators 2, 4 and 6. So what will be the next step then? Obviously you have to multiply with the help of this LCM on both the sides of given equation. So therefore next step will be multiplying both the sides by 12. Then we are going to obtain like this. Therefore 12 into n upon 2 minus 3n upon 4 plus 5n upon 6, which is equals to 12 into that 21 is going to remain as it is. So RHS number is going to as it is because we have to perform the operation on both the sides. So that's why it is very important to keep 12 on both sides. Now again solve that bracket, that means multiply with the help of that bracket inside of that bracket. So what will be the first number now? 12 into n upon 2. So that will be 12n upon 2. Then next one is 12 into 3n upon 4. Next number is 12 into 3n upon 4. So that also we had indicated here. First is 12n upon 2 because 12 ones are 12. But here 12 into 3n upon 4 plus next multiplication is 12 into 5n upon 6. 5n upon 6. So that is the third term. And on the right hand side 12 into 21, that is going to be 252. That is going to be 252. So by solving this now, if you that means simplify this equation, so you can simplify it very easily. Again 2 ones are 2, 2 6 are 12, again 4 3s are 12 and 3 into 3, that is going to be 9. In the same way 6 2s are 12 and here 5 into 2, that will be 10. So that's why we can write down it like this, 6n, because 2 6 are 12, then 3 into 3, that is going to be 9n, 6n minus 9n, that sign is going to remain as it is. And here 2 into 5, so you know the 2 stable and 5 stable also, so 5 2s are 10 or 2 5s are 10 and RHS is going to remain 252. Now the next step is simplify it, just perform the addition, subtraction, whatever we can perform according to the sign. So here 2 positive signs are there and 1 negative sign is there, and obviously the positive sign is actually positive numbers are larger than the negative number, so subtract the smaller number from larger number and final answer will have the symbol of or sign of larger number. So here 10 plus 6, it is going to be 16, and 16 minus 9, it is going to be 7. So therefore next step is 7n, which is equals to RHS is going to remain as it is, 252. Then dividing both the sides by 7 we obtain. So here we are going to divide both the sides by 7, then we are going to obtain like this, x is equals to, n is equals to, by mistakenly that was came, so n is equals to 252 upon 7, and by dividing it we are getting n is equals to 36. So here n is equals to 36. So this is the final answer. So by dividing on both the sides by 7 we are getting n is equals to 252 upon 7, and by dividing by 7 we are getting 36 is the final answer, which is the solution of the given linear equation. So in this way we can solve the fractional numbers or fractional equations, no problem, we can solve that, whether it is combination of fractional whole number or whether all the numbers are fractional numbers, no matter, we can solve it very promptly by using these types of method, and answer is maybe whole number or maybe fractional number. So in this example it is whole number, and in the previous example that was fractional number. So this is it for today. So stay connected with us. So in the next lecture we are going to consider remaining part of exercise 2.5. So thanks for watching the video. If you haven't subscribed our channel, please like, subscribe and share our page so you can get the updates about the future videos. Thank you for watching the video again.